In the wake of Storm Arwen, Malik and Corrie, we had power blackouts which ranged from 12 hours to nearly 48 hours. And I decided I wanted to get some backup so that I could keep going in the event of a future blackout. The result of that was this battery. This is a 2.4 kilowatt hour battery. Now, in a previous video, I discussed various backup power options, and this is what I settled on. I gave some brief demonstrations of what this battery was able to do. However, what I want to do is try and evaluate this battery in its fullest potential. So for that, what I'm going to do is switch off the power to my house and then run all of my necessities off this battery and see how far we can take this battery in terms of longevity. I'm planning for this power cut to my house to last for 48 hours. Now, if you haven't watched my previous videos, hello, I'm Anthony. I live in Aberdeenshire and I've got a 9 kilowatt solar panel array on my roof. There have been many videos which have discussed the performance, the value and the operation of this solar panel array. But today, instead of talking about energy saving, I'm talking about energy contingency in the event of a blackout. So here I am at my consumer unit. Now, rather than isolating the main incomer to the consumer unit and isolating the entire house, in this instance, I want to keep my photovoltaic system going and I want to keep my electric vehicle going. The reason for that is simply because these systems are part of a money-making and money-saving scheme. If I can charge my vehicle up tomorrow morning in sunny weather, then that means there is less dependence on me having to charge up my vehicle later on. However, every single other circuit is fair game. So right now I'm going to isolate my shed, sockets, fridge, hot water, lights, oven, sockets, and central heating system. And what else? Oh yeah, the cooker. So now I am completely isolated from the grid on my regular household consumers. Now, before we hook anything up to this generator, I want to talk briefly about safety. The thing to note about generators is that they are floating systems. That means that the ground potential of this generator is not necessarily the same as the ground potential for the general mass of the Earth. But what I want to do is check one crucial detail. What we're going to do is just check for continuity between Earth and one of the chassis pins. And that is very good indeed. This generator includes overload protection and it includes fault current protection, which includes line to neutral fault and line to earth faults. One thing it does not include is residual current protection. In the United States, I think you call it a ground fault circuit interrupter, or GFCI. In the United Kingdom, and I think the rest of Europe as well, they are called residual current devices. That's something I wish they included here. The other thing I wish they had was a main earthing bond terminal on the outside. So in my previous video, many people were asking about whether you could run the central heating system from the battery. And the answer is yes, but you need to be competent at wiring. Backfeeding the grid is a major hazard with this operation. When the grid supply comes back on, there's a major risk of creating a short circuit with your generator, causing a fire. So it's extra important to make sure that you've got discontinuity between your central heating circuit and your main consumer unit on both line and neutral conductors. So I'm opening up the switch fuse supply box feeding the central heating system, and I'm disconnecting the cable coming in from the consumer unit and replacing it with a temporary cable which I can plug into the socket outlets on the battery. So that's my central heating system wired up to a socket outlet. So now I can plug this into my generator. Now we're going to plug an energy monitor into here, And then we are going to switch this on. Okay, so we've got a fully charged battery here. We'll switch on the AC output. So we have got 230 volts worth of AC output. So let's plug in this extension cord into here. And what we'll do is we will select the power. As you can see, the energy monitor itself uses 0.5 watt. Okay, so now we've got this energized, we will now plug in my central heating. So now that is energized. So let's go and take a look at what we've got. So the central heating system, when the boiler is not running, is consuming about 3 watts. So the central heating system, as well as being composed of the boiler, we've got the programmable thermostat, and we've also got the motorized valves in the cupboard. That is all powered from this generator now. It doesn't use much power when the boiler is not switched on, and that's a very good thing. When the boiler is switched on, we'll have a look at the power consumption in that situation. So now it's time to plug in the fridge.
And this is where things go wrong. The dimming light you see in the fridge is because of a drop in voltage, which is caused by too much current being drawn by the compressor. And what's going on is that the compressor has stalled.
Okay, so that didn't work so well. We'll just check things out. Okay, so now it's time to plug in the fridge, and we'll just see how that works out. Okay, so now everything is switched on here. So the fridge is consuming 96 watts from this. It will not be running continuously at 96 watts. It is under thermostatic control, and when it's switched off, then it won't be consuming any power at all, in my experience. And here we are. Moment of truth. Let's see. Let there be light. And here we have got light. Finally. Let's put this back here. So one of the things to say is that I've now got a useful amount of light here. But there are some very interesting lessons learned from this. Number one, the compressor surge when the fridge freezer started exceeded 40 amps according to my energy meter. That is going to be a problem when it comes to routine cycling on and off. It will overload the generator and it will cut it out. The next attempt that I started it started just fine. It's just a very brief surge. Now, one of the things I noticed just here is that compact fluorescent lights also have a reluctance to fire up if they don't have sufficient electrical power behind that plug. That's certainly something you don't notice when you're on a grid supply, but when you're on a generator supply, there's a lot less power behind it. So things that require a bit of electrical oomph to get going, such as a motor or a compact fluorescent ballast, is going to be a problem. LED lights, I don't think, will be a problem. Now let's hook up the last item. Okay, time to hook up the modem. Let's switch this off here, and we'll just plug this in here. Oops, that's a Freudian slip. So, lights on, modem powering up. So, right now I'm all set for the evening. So, let's go on to the next thing. Now, people who have watched my previous videos will know that I've upgraded my kitchen, and previously I had a gas cooker. Now that's been replaced with this induction cooker. And here's the thing, in a power cut, you can't run an induction cooker on its own. However, individual induction rings will use
less than 1,000 watts if you're careful with how you use it. At full blast, each individual induction ring will use about 1,500 watts. At lower power outputs, you can keep it within the 1,000 watt power output limit of this cooking ring. But in order to do so, you'd need to open up this isolation switch, you'd need to remove your grid supply, and you need to wire in a flex cord outlet and plug it into your generator. That isn't really something I'm going to recommend doing. I do have another contingency. A camping stove. I can make perfectly adequate meals in a blackout situation with one of these. That's perfectly fine. In tonight's instance, I'll just simply be having some cold food, such as sandwiches. Other blackouts, I just simply go to my nearest village and get a fish and chips where I know the power is always going to be on. But it is possible to run this on a low power setting. So one of the things you can see here is that without the fridge freezer running, the power output here is just over 33 watts. But let's have a look at the other side. So here you can see the output from the generator on this indication is 60 watts. So what's the difference between the flux of power through the outlet socket and the flux of power on this indication? The fact of the matter is that at low power levels, the inverter for AC output isn't very efficient. With that in mind, if you've got things like phone chargers, you're best not using the AC wall outlet chargers because you've got a DC to AC to DC conversion inefficiency. Instead, you should plug your phone into the USB-A or USB-C outlets directly, and that avoids the need to use the inverter unnecessarily. And here's the result in terms of extension cables strewn across the floor in the hallway. Well, I've now settled into the evening time, and one of the things I will say is that my levels of comfort and entertainment are very little different from what I would have with normal grid supply. I've got almost normal levels of lighting in this lounge, for example, and my entertainment needs are completely fulfilled using my iPad and my Bluetooth speaker, both of which are low-powered battery devices in their own right. It's a much better compromise to use this instead of the more power-hungry television and audio system, which I also have. And it will keep my battery going for longer. But on the second night, I want to switch on the television instead of using the iPad, just to see how well the battery copes with a more power-hungry application for an evening time's use. So I've switched on the central heating system, and the AC power output from the generator has jumped from 60 watts to about 135 watts. And that is running the pump, the motorized valves, the burner and the igniter. And as you can see, it's not drawing too much load whatsoever. So we're coming to the end of the night now. I am going to be reconfiguring my extension cables very, very soon. Now, I have disconnected my fridge freezer. It will keep the cold in throughout the night time, but what I'm trying to avoid are those really strong compressor current surges from tripping out and overloading this generator. I want my central heating system to come on reliably in the morning time and warm up my house. But what are the things I can say is that this has made a dramatic difference to the comfort and enjoyment which I can have in a power cut so far. As we can see, there is just 1 bar of battery which has come off the battery scale. So we've got 4 bars of battery left. We started off with 5. So the power consumption has been very well controlled this evening. Well, it's time to run my extension cable into my bedroom. So I'm going to bid you good night until the morning. Good morning. So I am now in a nice warm house which I've got this morning. And this is one of the things which is unique about having a battery in this situation. We have the ability
to power up the central heating system and keep the house warm. Now, some people have considered installing a wood-burning stove so that they can keep their house warm in the event of a power cut. Now, the cost of installing a wood-burning stove with a brand new chimney is considerably more expensive than the cost of buying this battery solution. And you have to wonder, is it actually better to just simply get the battery solution and then have a power transfer switch which enables you to keep your central heating system running? It's a thought to ponder. Okay, so this morning we are starting the battery with 3 bars of power. So what we're going to do is plug the fridge freezer back in. So, time to make a cup of tea. I started the fridge freezer this morning and it was really struggling to start. It took about 5 attempts to get it started. So the day's starting to brighten up, but now I'm set up in my office. I have decided to keep my monitor and docking station switched off. I'm running on battery power for my laptop, just simply to preserve the battery on my main battery bank. I'm going to say, just learning from experience, I would probably switch off the AC inverter tonight. The inverter is very inefficient with very small power draws. If you have a demand of just 2 watts coming out of your outlet socket, it's going to be pulling more like 25 watts. So in preparation for the coming day, I'm going to bring this panel into the front of my house and my driveway where it's sunniest in the morning. Okay, so now I'm all set with the solar panel. Once the day gets a bit brighter, I'm going to bring my battery out here and hook it up here. So now I've got my battery hooked up outside in my driveway, and it's hooked up to the solar panel. It's not taking any displayed power input from this solar panel. It is a cloudy morning so far. So as you can see, I've now moved my solar panel into my back garden. Still no sunshine at the moment, but I can see brighter weather on the western horizon. There is a little bit of rain right now, so my bin bag is doing its job. We're down to 2 bars of battery out of 5 now, and I was really hoping that today was going to be a brighter day, but it looks like the brighter weather is going to be coming along in the afternoon now. Can you plug this battery into your house using a transfer switch? I cannot see any reason why you can't. So long as the loads that you have in your house are kept low, then your battery should be able to supply the lights in your house, and they should be able to run your boiler and other ancillary low load equipment without any trouble. But the more astute amongst you might be asking, can you use that battery to jumpstart this grid-tied solar edge inverter? That was a question I asked myself, and it turns out there is an application note on the Solar Edge website for running the Solar Edge inverter with a generator. Now, in that application note, it was referring to the use of having an automatic transfer switch. We also needed a dry contact on the generator, which was then wired into the Solar Edge inverter. That would then tell the inverter to have a wider tolerance for voltage and frequency. Those are the 2 attributes which the Solar Edge inverter is using to determine whether or not it's connected to a power supply which is running. But being an engineer that I am, I decided to apply some due diligence and ask the question directly to Solar Edge. Can you plug a battery such as the Bluetti EB240 into the house and use that to jumpstart your Solar Edge inverter? They responded with an emphatic no, you should not do that.
They told me that the application note that I referred to was only for large generators and it was not for the UK market. They also told me it was for the three-phase inverters. I found that a bit strange because the application note did make reference to single-phase Solar Edge HD inverters. However, they did tell me that is not the case. Now, as we've seen with the tests that I've done last night, having a fridge freezer switch on creates quite a large surge current. And when that happens, that's going to have an impact on the sine wave which the battery is producing. And when you've got a deformed sine wave which is going to be corrupted to that extent, what's likely to happen is that this will see that as a fault with the grid supply. They told me it could damage the inverter if the sine wave is of bad quality. Okay, so we have now got some weak sunshine. We've still got some high cirrus cloud, but nonetheless we're producing about 80 to 90 watts of power. That's enough to start charging up the battery and overcome the load that my house is currently using. But we're not going to get a full recharge today. And that means that when the sun finally falls behind the horizon, we will only have about 2 bars of battery power. So that means this evening we're probably going to have to find some ways of economizing on the electricity that we're going to be using. So finally we have got 330 watts of input coming into here. That is really impressive. This is a 375 watt panel and we're getting 330 watts input in Scotland at the beginning of February. Wow, I'm just impressed. So here we are in full bright conditions and I am just fantastic. Right, hopefully there'll be a little bit of charging up of this battery before the sun falls away. So after the day just gone, we had cloudy weather in the morning and we didn't get clear sunshine until 2 o'clock in the afternoon. At that point, we got 330 watts worth of solar power charging up this battery. That wasn't long enough. And the result is that we've got 2 bars worth of battery left, and that has to keep us going through tonight and into tomorrow morning. Now, tomorrow is forecast to be a much better day with bright sunshine right from the word go. So all I need this battery to do is to last me into this evening and tomorrow morning. And I'm going to have to do some rationing tonight. I'm going to run the fridge freezer for as long as I can. I'm going to run the central heating system just now, just to warm up the house a little bit. But after that, it's just going to be lights and modem, and I want to be switching on the fridge freezer after daybreak tomorrow morning. Right, well, it's now time for me to get ready for my bedtime. So I'll just wrap up today by telling you about the performance of my battery. The charge on the battery is shown with 2 bars. And we've had 2 bars of battery power for the last 12 hours. We had 2 bars of battery power since about 10 o'clock. There's been a bit of recharging during the afternoon, and we've had relatively light loads since I brought this battery inside. The fridge freezer's been cycling on and off. The central heating was used in the early afternoon, and we've just had the modem and the lights on throughout the evening. So I'm going to unplug the consumers from the battery, should I say. And then I'm going to switch this off. And then I'm just going to make myself ready for bed under the light of my lantern. And I'll get ready in the morning to use this battery for one last day. So this will be performing duty in the morning with my central heating as before. And then I'll switch on my fridge freezer and my modem. And then hopefully it will be a sunny morning and we can get this battery charged up. So I'm going to bid you good night and I'll talk to you again tomorrow morning. Well, it's the morning and I woke up about an hour earlier to switch my battery on and get the central heating going. We started off with 2 bars of battery power. We're now down to just 1 bar. So this is a nail-biting moment. Can we get this battery through to charging from solar power before we run out of battery? That's the big question, and I'll be looking forward to seeing what the answer is. Okay, so here we are. It's the start of a new day, and we will get this thing charged up. Let's see whether the sun comes up before this runs out of battery. Well, we now have an empty battery. As you can see, we've got error codes for both the AC and the DC. And it's quite interesting. The sun is just about peeking out now from the clouds. So I've got a feeling this will start to charge up before too long. And then hopefully we can get the battery going. This it's now what? It's 9 o'clock in the morning. So we've got 8 hours to go in our 48-hour test. And to get to this stage isn't a disaster. And if anything, it demonstrates to me that whilst this thing can go on for a long time, it doesn't necessarily mean it can go on for a long time continuously. So I'm going to hopefully get a nice spell of sunshine, and hopefully we'll see how well this battery charges up through the course of the day. So finally we got some sunshine. We're charging up at about 130 watts. If I show you what it looks like. So right underneath the lounge window we've got the first sunny spot. So now we've got good strength of sunshine, and we are charging at 270 watts. So this is where the power of solar power plus portable battery power really shows its true potential. I'm really looking forward to the end of the day and seeing how much we can charge this battery from, bearing in mind we had a completely empty battery for just a few short minutes. Okay, so what I'm going to do now is mount it back in its final resting position, and we'll call it an afternoon. Right, so now I've got about 2 more hours before I reach my 48-hour challenge, and I've got about 2 bars of battery returned. So we're almost at 5 o'clock. I want to just simply point out a few things. Again, we've had the photovoltaic system and the EV charger on throughout the whole trial period. This morning I also decided to cheat, and I put the hot water controller on. As far as I'm concerned, that's fair game. There was a lot of sunshine today, and I wanted to make sure that none of that went to waste. Yesterday, the hot water controller was switched off, and that was so that I could prove that the battery was capable of running the central heating system in order to deliver the hot water. But it is now 5 o'clock, so it's time to switch on the rest of the house. So we've got the shed. Very important. I need to start splitting some wood and get some more kindling. We've got sockets. We've got the fridge. Woohoo! No more surge stalls. We've got lights. Fantastic. More lights. Oven. Sockets. Central heating system. So we've got everything now back on in the house. So let's wrap this up. And let's talk about conclusions. So I made it to 48 hours of simulated power cuts in my house. This battery has got 2 bars of energy remaining on the indicator. Yesterday, in the early evening time, this battery also had 2 bars of energy in the indicator. However, I still think the state of charge this evening is lower than what it would be yesterday. So I've got doubts as to whether this would last me another day and get me to 72 hours. Now, I've learned a lot from this experiment. For one thing, overnight, you need to turn off all of the power. The inverter has got a certain level of overhead, even for the very smallest of loads. If you have just 0.5 watts of power demand in your socket outlets, then this will consume 25 watts just simply to run the inverter. Knowing how inefficient the inverter is, there are certain things we can do to mitigate that effect. I am going to take full advantage in future of the 12 volt output here. The modem, for example, uses a 12 volt power supply plugged in to the mains outlet. And you can also get 12 volt lights, which you can also plug in here. You've got lots of adapters which can convert from a car socket outlet to various barrel plugs. And you can also get multi-way extension sockets in a 12 volt format. That would mean that the only thing I'd need to use for the inverter would be my central heating system and my fridge freezer. And I can adjust the operation of that so that both are running at the same time. And knowing that the fridge freezer is good at keeping food cold for 12 hours at a time, it means I could keep the fridge freezer off for a much longer period of time. Now, would I recommend this battery? I'd give it a qualified yes. My only hesitation in giving it an unreserved yes is the reaction that this has to compressor surges when your fridge freezer starts up. So this is the PowekOak Bluetti EB240, and I think that I am ready for the next storm to hit me. Now, the Met Office is saying that the name of the next storm to hit us is going to be called Storm Dudley. Now, whether that hits northern Scotland, whether it's a damaging storm, and when it's going to hit, or even indeed whether it's going to hit, those are all questions which are unanswered at this moment. But all I can say is bring it on. I'd love to test this in anger and see how it performs. So I'd like to thank you all for watching, and I'll talk to you again very soon.